Hello and welcome to this session on information retrieval. Today our focus will be on evaluation. So let's say we have a collection uh, with 6 documents. So let's say the first document has IIIT Allahabad in it, the second document has IIIT Delhi in it, and so on. Just few words in each document exist. Suppose our query is Sri City. We wish to match those documents that contain the words Sri and city in them. So quite naturally, we would like to match D5 and D6. Let's say we built a retrieval system and our retrieval system resulted in IIIT Sri City and Kriya Sri City. So how good do you think is our system? Usually when I ask this question, the response I get is, oh yeah, it's very good. Yes, this is a character from the comic Tintin, one which is my favorite. I used to read it during my childhood days. I was quite impressed with this character. Anyways, coming back to the question. So now, how do we quantify this very good? So how good is this result? So that's the question that we will ponder today. So let me set the context. This is what happens in a retrieval system. We have a query. So let's say it's IIIT Sri City. It's being fired on a collection. So we have already seen that moving or changing the collection in the to a form of index, that to an inverted index, helps us in improving retrieval efficiency. So we have an inverted index which is derived from a collection of documents, and now that we have an inverted index, we fire the query on an inverted index, and our retrieval system tries to do the matching and returns the results. And we are now interested in asking this question: how good are our results? One way to understand the goodness of the results is to use human judges. The human judges would fire the same query on the collection, but they would do this manually, as in they would um, uh, go to the document set or the collection and manually look at the documents and figure out which document should match, and they, let's say, have annotated certain documents as appropriate for this query. So let's say we have some results obtained from the human judges which are manually derived. So now we have some basis, or what we call as a ground truth, to compare the results of our retrieval system against. So we have now some way to quantify, which we could compare these two results and quantify the goodness of the retrieval system, and that is our goal for today. Okay, so let's go back to our setting where we have a collection with 6 documents, and let's say now the query is IIIT. So I've changed the query. The query is now IIIT, and the, let's say, the results are IIIT Sri City and Kriya Sri City. Quite obviously, there is no IIIT occurring in the second result, Kriya Sri City. So it looks like this is a poor result, while the first one looks to be okay. If you look at the collection, so there are many more documents which contain IIIT in them, but those documents do not show up as well. So this doesn't seem to be a good result. So if I ask the same question, how good is our system? Usually my students would say, not so good. Again, we want to quantify this not so good. So the problem ahead of us is, if I were to ask you on a scale of 0 to 1 or on a scale of 1 to 100, if you could tell me how good our system is, what would you do? So let me reiterate the objective. We want all relevant documents and only relevant documents, right? So there are two parts to our objective. We of course want all relevant documents. So in this case, those documents are relevant that have the word IIIT in them. So that would mean D1, D2, D3 and D5 are relevant. So we want all the relevant documents, all 4 of them. And we want only the relevant document. That's the second part of our objective. So now let's go back. We want only D1, D2, D3 and D5. We don't want D4 and D6, right? So we don't want to see Kriya Sri City here for this query. So these are the two pieces that form part of our objective, which we want to use to quantify how good our system is. Okay, so how many relevant documents exist? As I said, we have four, all of them which have triple IT in them. And how many retrieved documents do we have? We have two of them, so triple IT Sri City and Kriya Sri City, and we don't like Kriya Sri City in our result. So the question now is how to quantify the goodness of our system. Let me introduce some terminology here. The documents that we see in result uh, are called positive. So we saw two documents, triple IT Sri City and Kriya Sri City. So let me go back. So triple IT Sri City and Kriya Sri City, which are D5 and D6. So the D5 and D6 are the positives here. Okay, so they turned up in the query. So that's why we call them as positives. And the all those documents that did not turn up are negatives. For example, D1 is a negative, D5 is a positive, D1 is a negative. Yeah. Okay, so these are my negatives. Everything else which is not positive is obviously a negative. Okay, and some more terminology. Documents that we correctly classify are true, and the documents that we don't are false. So we want to see triple IT Sri City. We want triple IT Sri City to be positive, and it was positive. So it is what we call as a true positive. At the same time, we don't want to see ISI. ISI should have been negative, and it is negative. So we call that as true negative. All right. So documents that we correctly classify are true. That obviously says that the documents that we wrongly classify are going to be false. Yeah. So which means Kriya Sri City is a false positive, and all these three documents which did not appear are negatives, and all of them should have appeared. So these are all false negatives for me. Okay, let's see if you have understood this terminology well. So let's do a simple exercise. Take a minute, pause a video here, and answer this question. Choose one of the best answer, one of the answers from below. All retrieved results equals true positive plus false positive, true positive plus false negative, true negative plus false positive, or true negative plus false negative. What do you think? If you're watching this lecture offline, please pause a video here and work this out yourself. For now, let's um let's continue with our discussion. So all the retrieved results, right? So everything that is positive is retrieved. So what are all the choices that we have? So the true positives are the retrieved ones which are good, and the false positives which are the retrieved ones which are bad. So the true positives and the false positives together make all the positives, and that's why all retrieved results are simply TP plus FP. Great. How about all relevant results? What do you think? Pause a video here, pause this video here, and solve this yourself. If you have not solved this yet, I suggest you pause the video here and solve it yourself. So I'm going to go ahead and solve this now. Okay, so if we are asking about relevant results, we are asking for true results, right? So anything that is true on the positive side would be true positive, and anything that is um uh, false negative would also be a relevant result. Why is false negative a relevant result? So what is a false negative? Uh, Something did not show up in our results, that's why they are false. And they are negatively false, which means they were relevant, but we did not show them to the user. So they are false negative. So if we put together the true positives, which were rightly shown and which were wrongly hidden, which is false negative, we have all relevant results. Hope you got this one right. Let's move on. So if we say that you have 100% precision when everything you retrieved were relevant. Yeah. So your retrieval system has 100% precision, or it is precise if everything it retrieved was relevant. So let's say yeah, in this uh, in this query, if we had only got one result, and it was, let's say, triple IT Sri City, then everything that we retrieved would have been relevant. So we would have got good precision, or 100% precision. In other words, we don't want to see any false positives. Yeah, so false positives should be zero. And another way of saying this is the true positives plus false positives should be the same as true positives. Okay, so now let's talk about the other part of our objective. We seem to um, we say that we have 100% recall when we retrieved everything that were relevant. Um, so if our system has 4 relevant documents, we want to retrieve all 4 of them. Yeah. So in that case, we say that we have 100% recall. Um, so what does this mean in our terminology? It means that the true positive count matches all the relevant documents that we have in our system. Okay. If true positive covers all the relevant documents, it's needless to say that there should not be any false negative at all, because we have covered all the true documents on the positive side. Okay, so let's try to do one more exercise. Let R refer to relevant documents, and N refers to a non-relevant document. Okay, uh, our collection has about 10,000 documents. Assume that there are 8 relevant documents in total in the collection for the given query. So whatever be the query is, we are not interested in the query right now. Whatever the query is, let's assume that only 8 relevant documents exist in total in the collection. Now, can you calculate the precision and recall if the retrieved documents were like this? So in this notation, what this means is the first document that I retrieved was relevant, the second document I retrieved was relevant, the third document I retrieved was not relevant, and so on. So I have 20 results. So out of the 20 retrieved documents, so I have 1, 2, 3, 4, 5, 6 relevant documents, and the remaining 14 are non-relevant documents. Now the question is, how good is this system? Can you objectively give me a measure in terms of precision and recall for this system? Again, pause the video here and please try to solve this yourself. Okay, so let's go ahead and try to solve this. If you have not solved this yet, please pause the video here while I continue to solve this. Okay, uh, let me see if I can get my pen working here. Okay, so how many relevant documents do we have? You might have noticed this already. Um, so I have 1 relevant, 2, 3, 4, 5, 6. So we have 6 relevant documents, and and the number of non-relevant documents that were retrieved equals 14, right? So number retrieved equals 20 and our collection size is 10,000. All right, so these are given to us, and there's also another important data that is given to us, that there are in total 8 relevant documents, right? So if there are 8 relevant documents in our system, and if we have only retrieved 6 of them, um, then how good is our recall? So our recall is simply 6 over 8, right? So there are 8 relevant documents, but we retrieved only 6. All right. So let's talk about the precision of our system. I'm sorry about these horizontal lines. This seems to be some bug in PowerPoint. They just seem to appear. Um, okay. So what would be the precision? The precision is what is the um, fraction of the retrieved documents that are relevant, right? So I retrieved 20, so that's on the denominator, and out of the 20, only 6 were relevant, right? So I'm precise to the extent of 6 over 20, and I have a recall of 6 over 8 because there are only 8 relevant documents. I expected to retrieve all of them, but I've retrieved, or I managed to retrieve only 6 of them. Okay, so that's why we have a recall of 6 over 8 and a precision of 6 over 20. I hope you got this right. Um, and this combination of precision and recall gives us a way to objectively or to quantify the goodness of our retrieval system. So what did we do so far? Let me formally introduce the idea of precision and recall here. Precision is simply a fraction of retrieved documents that are relevant. In other terms, it's the probability of a relevant document given the retrieved document. Recall is a fraction of relevant documents that are retrieved. It could also be mentioned as a probability of retrieved documents given the relevant documents. Okay, so if we have the notion of true positives and false negatives and so on, then we could say that precision is simply TP over the sum of TP plus FP. So that's all positives. So we take all the positives and then see what fraction of it is true. And if we are talking about recall, it's a fraction of what fraction was true when considering the relevant documents, which is simply true positives plus false negatives. I hope this is clear to you so far. So let's move on. Let's do one more exercise to ensure that we understood the idea correctly. Suppose a document is relevant only if both judges agree that it is relevant. Let's say I hired 2 judges to manually go and explore the collection and annotate documents as either relevant or non-relevant to a given query. So in this case, the query is Taj, and I have 2 judges, judge 1 and judge 2, who is looking at each of the 5 documents that I have, and he's marking if the document is true or false. And I'm telling you that I consider only those documents as relevant where both the judges agree that the document is relevant. Okay, so in the table below, 0 means the document is non-relevant, and this is marked by the judge, and 1 is relevant. So our objective is to find the goodness of the system in quantifiable terms, or we want to find the precision and recall. Okay, so let's look at this table. So we have the query Taj, and we have the 5 documents D1 to D5. And let's say I gave the document D1 with brew written on it, and judge 1 feels brew has nothing to do with Taj, so he gives a 0 rating, which means it's non-relevant. Judge 2 also looks at D1 and also feels that D1 is non-relevant. So both the judges think, they agree that this is not a relevant document. Now let's take the case of Taj Mahal D5. Now in D5, we have Taj and Mahal, so it's Taj Mahal, and the query is Taj. So since the query is Taj and the document has Taj Mahal, the judge 1 thought it is relevant, so he gave a 1. But Judge 2 somehow thought this Taj is referring to tea and not to the popular monument Taj Mahal. So this document is not relevant. Perhaps Judge 2 saw that this query is coming in the context of multiple queries where the earlier query was about tea or coffee. Or it comes from a place which is known for tea, like let's say Assam. So for some reason he thought it's 0. Okay, so in this case, we think that this document is not relevant because we want both the judges to agree on relevance, right? So that's what we saw here. So we want both of them to agree that it is relevant. Okay, so how many relevant documents do we have for this query? So we have only two. The D3 document which is Taj, and D4 document which contains Taj T. Okay, and now let's see what our system did. Our system retrieved D1 and D3, and it did not retrieve the rest. Now the question is, how good is our system? Please pause the video here and try to find out the precision and recall. Okay, let's try to solve this now. Uh, so first let's go for the precision. What do we think the precision is? So the precision is the fraction of the retrieved documents which are relevant. So how many documents did we retrieve? We retrieved 2, D1 and D3. And out of these, only 1 is relevant. Right? So let's derive the relevance here. So we know that this is relevant, and everything else is non-relevant. So we want 2 ones to be qualified to qualify this document as relevant. Okay, so that's why P becomes 1 over 2 or half. What about recall? Uh, Recall is the fraction of uh, relevant documents amongst all the relevant documents in our system, the retrieved relevant documents over all the relevant documents that we have in our system. So how many relevant documents do we have in our system? We have 2 relevant documents and we expect to retrieve both of them, in which case the relevance would have been, the recall would have been 1 if I had retrieved both of this. But I retrieved only one of this, so again recall is also half. Okay, so in our terms, if you want to call these, you could also call these as the first one, D1 is false positive. It is positive because it is retrieved, and it is false positive because it shouldn't have been retrieved. It's a non-relevant document, whereas D3 is a true positive, right? So precision, and say, okay, let's continue to do the negatives as well. So we have D2 as a true negative. It shouldn't have been retrieved and it is not retrieved. Similarly, D5 shouldn't be retrieved and it's not retrieved. So these are true negative documents. But D4 is a false negative document. It should have been a positive document. So we call it a false negative document. Now that we know what the true positives are and true negatives are, we have the formula to put this in and get the precision and recall. So the answer is 1 over 2 and 1 over 2 for both precision and recall. I hope that is clear to you. So now we have a way to quantify the goodness of our system. So let me summarize where we are at the moment. So we are building a retrieval system, and the retrieval system's job is to match the user given query to a collection of documents. So the way we proceed is, first we create an inverted index. We have many different strategies to create inverted index. So one of them is the inverted positional index, and To arrive at an inverted positional index, I have to look at the documents, tokenize them, case fold them, stem them, remove the stop words or lematize them, and then convert them into an inverted index. So once I have the inverted index, I can match the query with the index quite efficiently and retrieve the matching documents. Now that I have the matching documents, I am interested in finding the goodness of my system, and I am asking what is the precision and what is the recall of my system. Or in other words, am I retrieving all the relevant documents and am I retrieving only the relevant documents? So these are the questions that I'm asking. And to answer this question, one way to do that is to have human judges to look at the same collection of all the documents and come up with a list of results and compare. And we compare the manual. We assume that the human derived results are the ground truth, which is the right one, and we want to ensure that our retrieval system matches the human observation as closely as possible. So comparing these two results, we could derive two metrics, precision and recall, which can say how good our system is. So what happens in the real world? So let's say you are in Google, Bing, Yahoo search, or you're building a custom search engine. What would you do? So you would first build your search engine, and parallelly you would have some humans look at the common queries, which we call as the head queries, the queries that appear with a lot of with high frequency, the popular ones, and we also have tail queries, the not so popular ones. So we have lots of head queries and some tail queries, and we mix them and we sample them and we give it to the human judges. The human judges would go and figure out which document should actually match, but this is usually a very challenging task because the document size is huge. If you have trillions and trillions of documents, finding out the right document could be very, very, very tricky. So how do they do this? So we'll keep that for discussion uh, in the later parts of this course. But for now, let's assume that we had somehow figured out the relevant documents and the judges have that list. Then we could compare that with our results and say how good our system is. At least finding out precision is not that difficult because you have a limited number of documents. So you retrieve 20 documents and you are asking how many of them are relevant. So you could look at the results and judges could say, yeah, this is relevant, this is not relevant. So computing precision is easy that way, but computing recall is going to be very difficult because judges need to know how many relevant documents exist in the system. So they need to know all the relevant documents that we have in the system to compute recall, and that's usually a big challenge, and it's computing that is not easy. There are many tricks to do this. One trick is to come up with a synthesized collection where you put known number of relevant and non-relevant documents, and put, let's say you have 10 relevant documents, you put them and then put some 2000 non-relevant documents, right? And you now have a synthetic collection, and on that collection you run our system, fire the query and see whether you can compute precision and recall. So this is just one trick. There are a few interesting strategies which we use to overcome this limitation. We'll discuss them in future classes. Thank you.